Hello, everyone. First of all, thank you to everyone for not walking away right after the best paper nominee presentation. We appreciate that. And also, if you are wondering, yes, I am the volunteer who told you if you got lost or drunk during the poster session. SFU takes no responsibility. In my defense, it worked partially. At least we know nobody got lost. All right, for this paper, I co-authored this paper with my advisor, Dr. Alyssa Weiss, and also there was Belinda Wan Qijin, who, by the way, designed the conference logo for this year, and also our team T-shirt. This project started at Simon Fraser University and continued at New York University. In this study, we continued our investigation of the interaction practice in large-scale learning environments through the analysis of artifacts left behind by learners and instructors. This is our MOOCology research project. In the current study, we investigated discussion forum interaction through a social analytic perspective. Actually, before constructing any networks for investigation, our team decided to review different ways that researchers use to define social ties in discussion forums. And also, we wanted to know the effects that different tie definitions may have on the resultant networks. Moreover, we were interested in comparing three kinds of social networks: the one formed in the overall discussion forum, the one formed in discussions related to course content, and another one that is formed in other kinds of activities. On top of that, we were interested in knowing whether interactions in the discussion could help us to understand distinctions between different social networks. The data we used were post hoc data provided by Stanford, generated on in a MOOC on statistics in medicine. The discussion forum had a 3-level posting structure and was facilitated by 2 instructional members. A total of 567 users made over 3,000 posts in 817 threads. The discussions were first petitioned based on whether or not they are directly related to the learning of the course content. We made data petitioning at thread level to keep the intact conversation context. And content-related threads are Q&As, comments, or discussions related to the course subject statistics. The rest of the discussions were considered non-content. They could be logistical or technical questions or socializing talks. In previous studies, our team found that content-related and non-content-related discussions have distinct linguistic features. Using those features, we developed a post classifier and later on the diptych categorization method for discussion threads from statistics MOOCs, and we got pretty good accuracy. In the current data set, 468 threads were categorized as content-related, and the rest, of course, non-content-related. We also found of all the participants in this forum, only 28% took part in both kinds of discussions. Now let's look at the tie definitions we reviewed. The first one was direct reply, according to which if one actor replies to the post of another, they too share a tie. The second one was star. Any actor who posts in a thread shares a tie with and only with the thread initiator. The third one was direct reply plus star. It is the combination of the first two without double counting any tie. These 3 definitions actually all define social ties based on reply relationship between participants in the discussion forum. A different perspective to tie definition could be co-presence or co-participation. For instance, total co-presence considers that all actors who post in the same thread share ties, no matter they responded directly to each other or not. Another variation of co-presence could be limited co-presence, which considers actors who post in the same thread may not read all other posts in that thread, especially when the thread is a big one. So the actors may only share ties with a limited number of co-participants. There are, of course, many different ways to set conditions for limited co-presence. For this current study, we set the condition that if a thread contains more than 5 posts, then actors only share co-participants-based ties with co-participants in the same subthread. So using these 5 definitions, we extracted social ties from content-related, non-content, and unpartitioned discussions, and built social networks in Gephi. For the purpose of comparison, we made the networks non-directed and also with weighted edges. We first compared 3 kinds of network properties: number of edges, average node degree, and average edge weight. From left to right, the colors stand for networks constructed based on direct reply, star, combination, limited, and total co-presence. In general, we can see the first 4 definitions produced similar results. For instance, in the content-related network, the average edge weight of the first 4 networks are quite similar, but total co-presence produced a much higher result in this network. And similarly, in the other 2 kinds of activities, non-content and unpartitioned, total co-presence produced a dramatically higher number of edges and average node degree. Then we moved on to look at the social network structures, again arranged from left to right in the same order. Different colors in the graphs stands for modules or clusters of connected people in the same network. Also here, the size of the nodes represents degree centrality. Again, we found the first 4 definitions produced similar network structures. For instance, when we look at non-content activities, we found both in terms of the number of major modules and the central nodes, they are very similar. However, again, when look at total co-presence, we found more differences. For instance, in the content-related network, there was a 3rd module that has super strong ties standing out. And when we look at non-content and unpartitioned networks, the 2 green balloon-shaped modules are very eye-catching. To figure out what was happening there, we examined the contributing posts to this balloon-shaped module and found most of them are from a self-introduction thread. One learner initiated this thread early in the course, and 87 other people replied to that thread. So based on total co-presence, all these people share ties and formed this module. And also at the same time, as they are all considered connected to each other, they gained the same similar social degree in this module. So nobody stand out as a central node. But when we look at the other 4 networks, because of receiving all these replies, this learner gained higher social degree, therefore became the center of a module, although this person never ever posted another contribution through the whole course. So from this comparison, we can see that total co-presence as a tie definition produces very different networks from the other 4 definitions. And also because it is sensitive to superthreads, it could be useful for detecting inflated social status due to initiating superties. Another important finding is direct reply and total co-presence are the 2 most commonly used tie definitions in MOOC literature. However, they produce dramatically different networks, both in terms of property and structure. So this may help us understand partially the disagreeing findings from SNA literature. Following this, we proceeded to compare content and non-content related networks, as we are interested in understanding social connections formed through reading, not just the writing, but also reading of the posts. We wanted a definition that was based on co-presence. However, as total co-presence is problematic, we proceeded with limited co-presence. When looking at the network structures, we found the modules in the content-related network on the left have very strong interconnections, which means there were a lot of interconnections between people in different modules in this network, which was less common in the other network. Also, the average node degree and average edge weight are both greater in the content-related network, which means actors in this network developed social ties with a greater number of people, and also they developed stronger social ties in the same process when they participate in content-related discussions. To dig deeper, we extracted all modules in the two networks that contained more than 5% of the network population and looked at them. We got a total of 7. 3 of them only contained learners, and the other 4 each contained an instructor. Let's first look at the learner modules. Here, the orange one was from content-related network, and the other 2 non-content. When looking at the structure of the orange module, we can see it is highly interconnected with super strong ties connecting multiple central nodes, which means social connections in this network is more robust than the other 2. Even if 1 or 2 central nodes quit the forum, other members still get to keep a big proportion of their social connections. As in the other 2 networks, if you two in the first one or the little guy in the middle in the second one quit the forum, the network would largely fall apart. In addition, we also found by examining the social network properties, we found that in the orange module, the content-related one, learners developed stronger social ties with a greater number of peers. While holding this question, we looked at the discussion interactions in different modules and found several characteristics of the content-related module and discussion that could help us to understand the social network distinctions. First of all, a greater number of threads contributed to the orange module. That means learners' interaction and the connections are more distributed in this module. Secondly, the same learner made a greater number of posts in the same thread, suggesting they may have revisited the same conversation more often. And last but not least, threads in the content-related module contain a greater number of posts, which may suggest a greater depth or complexity of the conversations. And these assumptions and findings were echoed by our findings from the qualitative examination of the discussion posts. We found content-related discussions quite often involve more complicated topics, such as understanding of abstract concepts or problem-solving process. Learners used more diversified techniques to communicate. For instance, they asked follow-up questions, they used examples, and they paraphrased themselves. And also, they used a lot of social presence cues in their conversation. In contrast, the non-content-related conversation mostly involved straightforward exchange of factual information, and once the information was delivered, the interaction in the thread quite often terminated. This conversation exemplifies how learners interacted, connected around content. We can see back and forth between different learners, and we can also see one learner here said, all these people, your discussion helped me so much. Glad I was able to catch up in the last weeks. And also another one said, I thought of my discussion board friends often. Isn't that sweet? So from this conversation, we can see that besides learning, learners seem to have also developed strong interpersonal bonds with each other. Next, let's look at the instructors. Here are the four modules that we found contained instructors, U1 and U4-17. When looking at the structure of the network, the first thing we may notice is they are all hub-and-spoke structures, with the instructor being the only central node at the center. This means interactions in these modules are highly instructor-centric. After looking at these structures, similarity is one thing that we noticed, the structure of these networks. But after we made instructor-wise comparison between the social networks, we found important differences between the networks around the different instructors. In the network around that contain instructor U1, both in content and non-content networks, we found learners developed stronger ties with a greater number of people than their peers in the other two modules. So this difference between the social networks and actors in the networks could in some way be explained with the instructor's difference when they intervene the actions. For instance, instructor U1, we found responded to posts at all levels, post starters, reply posts, and reply to reply made by other learners. Also, this instructor revisited the same conversation very often. When intervening learners' activities, this instructor used many techniques to help learners work out the answer or the solution. And also, he or she used social presence cues quite often. For instance, we can look at two examples here. Think about it again using the hint and let me know if you have any other questions. And also, that is correct, nice. So how would you use this to solve the question? In contrast, the other instructor only responded to thread starters and never made more than one post in the same thread. Also, in most cases, this instructor provided straightforward answers to learners' questions, which actually could be considered efficient intervention in some contexts. And also there we put up another example from this instructor, and you can tell the difference between their intervention approaches. So, after all this analysis, take-home messages, first we found tie definition does affect the resultant network and the interpretation of the social networks. So purposeful selection of tie definition is important for SNA study. Second, content-related and non-content networks had distinct characteristics, and they could be useful for different research and teaching purposes. And finally, content-related discussions led to wider and deeper learner connections. Also, instructors' intervention approach may also have affected it. So research along this line could be useful for informing both design of learning activities and intervention strategies. So that is all. Thank you very much. We would like to hear your comments and questions. Thank you.
Was there any relationship identified between the total co-presence model and proportion of discussion that was actually content related?
The relationship between, you mean the structure of?
Yeah, essentially, like was there a relationship between having more, let's say, group discussion and discussion that was focused on the content of the course rather than non-related things?
Not really. The distribution of content and non-content related discussions in this dataset was not very different. There's slightly more content related discussion than non-content, but I wouldn't say that would influence the network structure of the total co-presence one.
I'm just going to add that those are two different questions. So the two different divisions, one was looking at which threads were content related and which were not. Separately, we applied the 5 different tie definitions. So the tie definitions were applied to the same content, non-content division after the course had completed, so they couldn't have affected how students interacted.
Yeah, so I think it's really very important to look at the bias that we introduce by the tie definition. So I think this is a very important contribution. I would just draw your attention to another possible bias. I mean, the basic network measures, centralities are well defined, but you have used modularity. And if we come to cohesive subgroup definitions, we again have very different methods that themselves have biases. So which method did you exactly use for the modules? Just standard modularity, Gerber-Newman, or in Gephi, I guess you have the Louvain method?
Yes.
Yeah.
Yes.
So this is also something to think about. It's another source of bias because depending on the definition of cohesive subgroups, you may get completely different results. You have, for instance, methods that only give you partitions, no overlaps. You have methods that give you potential overlaps. So it's very important also to reflect on that. And I think given the situation, the rich situation in the content-based networks, it was, of course, very good to see that the content-based networks are the richer ones in a way. You might also look at methods that maintain the bimodality of the network. I mean, between forums and speed the posts or the posters. Yeah, so that could resolve structures in a better way than just looking at the induced actor-actor relations. There are methods that might resolve the situation much better if you stick to the original bipartite graph. So that would be another possible thing to look at. Yeah. But very interesting. Thank you.
Yeah, thank you very much, Professor Haupt, for your suggestions. Actually, during the literature review phase, we did look at some work that constructed networks based on actor and forum bipartite connections. And after this research, we reviewed those literature again and found interesting connections between our findings. For instance, some work has found that the discussion subforums that are focused on course content or final projects actually have higher shows higher learner persistence and a lower percentage of one-off ties, the weak ties among learners. So I think it would be really interesting to look at this social networks from using different methods and from different perspectives. And this also well, thank you for bringing this up. Actually, we've been thinking that in the future studies, it would be interesting to use one limited co-presence condition on different data sets to compare the results. And also, it could be interesting to apply different limited co-presence conditions on the same data set and see how it would be similar or different. This would all help with the development of the analysis methods in this regard. Thank you.
Hi, thanks. That was a really interesting talk. I was just wondering, so this was just run on the discussion forums for a single statistics course, and I was just wondering if you had any view on how much these network patterns might differ or be similar in different courses on different topics, if you have any perspective on that.
In this study, we only used data from one course, so I will not be able to really make a lot of comments before I look at more data. But we did notice that in some of the previous works that used total co-presence tie definition in their network graphs, we noticed the balloons. So it seems promising that when we look at more data, we probably would see some similarity in the patterns. Thank you.
Yeah, so maybe attaching to the last couple of comments, things like introduce yourself thread is very common in MOOCs. So you could think of that point or that thread as an outlier or a high leverage point and just say, if we find it, we just ignore it. And then that raises the question of, how do you differentiate when you want to say something like these networks look very different depending on our kind of definition, our operational definition of ties? And we can look at them with some of these classical network measures that you're counting, but of course those are direct consequences of the operationalization, so it's not so much a test of whether the network is a different network. So a suggestion is to invoke a statistical network model that you could then say, are the structures that are meaningful to me still there, regardless of whether the tie formation is defined in this way or that way, given sort of what the generating process for this kind of network is. And then that would say these networks are different in a statistical sense, rather than they're sort of different because we operationalize them differently.
Thank you for the suggestion. In the scope of this study, we didn't get to do more statistical analysis between different tie definitions. That is one of the things we want to work on in the future. And also I want to say for the purpose of reviewing different tie definitions originally was because we found in the literature, researchers do not always explicitly justify their selection of the network construction methods. So we wanted to see how different, how much this would influence the resultant network.
Oh yeah, no, I agree that was really good to do that sensitivity analysis.
And also I think in the future we would like to do more analysis, not just based on the network properties, but also we would like to bring in more variables. For instance, we could also look at the overtime involvement of the networks and see how definitions would help us to, different definitions would help us to understand the progress of the network development and also the retention, and probably we could also tie that to learners' learning orientation or their learning outcome. Thank you.
We have time for one last question, if there's one. Otherwise, we'll thank the speaker.
Thank you.